What is up, Algebra 1? We are going to go through factoring, solving, modeling, and analyzing quadratics. The only thing I want you to know is quadratics are always in the form 0 or y equals ax squared plus bx plus c. Okay, now we use the x method in class. So we drew our x, we did our a times c on top, our b on the bottom, and we divided both sides by a. Now, this is, the way to do it by hand, but we're going to go through how to do all these problems quick and easy using Desmos. So an equation is shown what values make x true. Watch what happens when I type this in. 2x squared minus 5x minus 3 equals 0. Okay, so here's my quadratic. Without the equals, I see my quadratic. With the 0, it still works. You're looking for our intercepts, where our lines cross the x-axis. So here's our answer: negative 0.5 and 3. Negative 0.5 and 3. Okay, we can get away with doing this on almost every single problem. So select all of the expressions that are equivalent. So again, if I pull this up, I'm going to type in my first one. So 9x to the 4th minus y squared. And you notice I have an error. So what I can do is if I put this equal to 0, I can take this and move it to the other side and make it positive. So when I move it to the other side of the equal sign and make it a positive y squared. Okay, so here's what my graph looks like. I'm trying to see which of these look the same. So let's try the first one. 3x squared minus y, the second power. Set it equal to 0. I can see that only gave me half. So it can't be that one. Try the next one. 3x squared minus y squared. Again, I get this. I just set it equal to 0. That matches up perfectly. So that's good. Okay, keep checking. Let's try 9 times x squared. Oh, I forgot my squared. 9x squared minus y squared equals 0. Matches up perfect. Okay, the only difference here is we have our 9 on the inside. Let's put our 9 on the inside here. Not the same. And our last one. 3x squared y plus y times 3x squared minus y. And again, equals 0. Perfect matchup. That works also. There's lots of tricks for Desmos. We're trying to see where they're equivalent. So by graphing this and then graphing all of these in Desmos, we can see which ones have the same graph. If they have the same graph, then guess what? They're equivalent. If they don't have the same graph, like these two, then it's not equivalent. All right, which correctly factored form of function can be used to identify the 0? Again, we're going to cheat the system. So we're going to type in our question. So we have f of x, lowercase, equals 36x squared plus 15x minus 6. So here's what my graph looks like. And all I need to do is see which of these is the same. Okay, let's start with the first one. 12x minus 2, 3x plus 3. Okay, you can see they don't overlap perfectly. Those aren't equivalent. We try the next one. 12x minus 2 and 3x plus 3. Still not matching up. Try the next one. 3 times 4x minus 1 times 3x plus 2. My graphs perfectly overlap each other, so I know that that's my answer. All right, on to the next one. Okay, a function is shown. What is the minimum and the maximum? Okay, into Desmos. Clear it out. Let's find our minimum value. 5 times x minus 2 squared plus 3. The minimum value, the lowest point, is 3. 2, 3. The minimum is right here, 3. Okay, let's do the next one. Equation is given. What is one solution? (48) equals 4x squared plus 12. Here are my two solutions. I only need one. 3 or negative 3. Or 2. 3 and negative 3. Same thing. An equation is given. Find our answer. Delete this out. Type it in. X squared plus 9 equals 6x. I can see, here we go. The answer is 3. Okay, an equation is shown. Let's type everything in. 16x squared plus 10x minus 27 equals negative 6x plus 5. There's our two answers. Now, if you are ever getting an error, remember, we can move these to the other side, and we just flip the signs. Negative 6 becomes positive. Positive 5 becomes negative, and we still get those two answers, negative 2 and 1. Okay, next. A grasshopper jumps off a tree stump. Here's our equation. This is a good one to do because when we put this in Desmos, we need to make sure that we use x's instead. So x negative x squared plus 4/3 x plus 1/4. Here's what my graph looks like. Here's our grasshopper. He jumps. And after how many seconds does he hit the ground? Right there, 1.5 seconds. Okay. Use a point tool to show the x-intercepts and maximum or minimum of the function. Okay, Desmos, here we go. X squared plus 2x minus 3. Here's my graph. Here's my intercepts, negative 3 and 1. And here's my minimum, the negative 3, 0, and 1, 0. And our minimum was at negative 1, negative 4. And there's our quadratic. The graph of a quadratic function f of x intersects at negative 3 and 5. What is a possible equation? Well, that means if we put it in factors, we just have a positive 3 and negative 5. So if we go here, one easy way to do this is if we just try one. X squared plus 1x minus 5. Okay, so one easy way is you could just guess and check until you find it. But we know these are our factors, so if we factor, we have x squared, and we have negative 5x, positive 3x. Those combine to give us negative 2x. And our last thing, negative 15. These have zeros at negative 3 and 5. Okay. Which function is equivalent? Again, here's a great time when you see that word equivalent. It means that we can type them all in and see which ones are the same. Okay, so here's my function. I want to see what is the same. So x plus 3 squared minus 9, not the same. X plus 3 squared minus 18, not the same. X minus 3 squared minus 27, not the same. So it must be this last one, which is the same but minus 36. And there you go. They overlap exactly, so it must be D. The manager of a company uses a function shown to model its daily profit based on the price of a product in dollars. What is the maximum? What is the minimum, maximum? What is the greatest profit? Okay, so type it in. We have x minus 22. And we have 53 minus x. Can't see it, but it is there. Here it is. So what is the minimum price? The minimum price is here, 22. We can't be negative. We can't have a negative price. Our maximum price is 53. And our greatest profit is up here. So if we sell 22, we make $0. If we sell 53, $0. Maximum right here. What is the price in dollars? $2.40. We have 22, 53, and we have 37.5. Here's the graph of the function. What is the domain? So remember, those are x values. This graph is going to keep going and going and going forever this way. And it will go forever this way. All quadratics, the answer is all real numbers. Always all real number for quadratics for the domain. Use the point tool to plot the zeros. Again, we type this into Desmos and we can plot it. I don't need to do this again, but you just put it into Desmos and plot it all in. Which graph represents the function? Easiest way to do this is to graph it in our graphing tool in Desmos. Negative 0.5 parentheses x minus 4 squared plus 1. Here's my graph. The only one it seems to match with is B. Okay, here we go. The graph of the function. What is the minimum value? Here's our minimum. It's 2. The lowest point. X values, Y values. When it's asking for minimum and maximum values, we use Y. Which function has a greater maximum value than f of x? Okay, so if we're plugging all of these in, you plug them all into Desmos and you'll see that a is the only one that has a larger maximum, which this maximum is at 4. This one has a maximum at 5. And that is everything you need to know about quadratics factoring. Remember, Desmos is going to be what you want to use on those questions. All right, see ya.